Hello students, welcome to another tutorial on mechanical properties of matter. In this video, we're going to start by introducing Archimedes' principle, and after that we're going to see if we can use this principle to work out a question I left you guys with in the previous video. So the question I left you guys with is this question. So I hope you had time to go through the question. I hope you tried it out. But then if you struggled, you can just go through my description of Archimedes' principle and see if you can apply them to work out the question. If you did not try it, you can just pause the video right now and see if you can have it go at it. Now, before we go any further, before we even describe what Archimedes' principle is, I'd like to remind you guys of a concept that you learned back probably in lower grades or something. So let's look at this scenario. So let's say you have an overflow can, and this is filled with a fluid or a liquid. So I hope by now you know what this experiment was all about. So in this case, you were trying to determine the volume of an irregularly shaped object. So this side, you would have a beaker or a measuring cylinder. So if you immersed an object fully into this fluid, what would happen is that it is going to displace some amount of water from the overflow can into the measuring cylinder. And if you guys recall, the volume of the water you'd have this side, this volume here, would be equivalent to the volume of the object that you immersed. So this is the experiment you use to determine the volume of an irregularly shaped object using the displacement method. Now, Archimedes noticed one thing. He noticed that if you immerse an object in a fluid, whether partly or wholly, what would happen is that the object you immerse inside the fluid will experience an upward force. Now, this upward force, he called it the buoyant force. So in this case, we use FP, F subscript P, to mean buoyant force. Now, the buoyant force each object will experience will be given by, or will be equivalent to, the weight of the displaced fluid. So if we can find the volume of the displaced fluid, this V here, its weight will actually be equivalent to the buoyant force that the object will experience. Now, this buoyant force will act upwards through the center of mass of this object. Now, this kind of explains why objects would tend to feel lighter when they are immersed in a fluid. Now, let's see what exactly happens for an object that is immersed in a fluid. So if you have a container again that has a fluid inside, and then you immerse, let's say, now this time partly, you immerse an object, but not fully, just partly. Now in this case, it is important for you to note that the volume that you actually have to work with to determine the buoyant force will be this section that actually gets into the fluid. You don't talk about this part that is outside. So this doesn't contribute to the buoyant force. It is the section which actually gets into the fluid that contributes to the buoyant force this object experiences. Now let's go back to the first case where an object gets immersed fully. Let's look at what forces will act on this object. Now in this case, what you guys should keep in mind is, firstly, you have the weight of the object in air. So this weight or this force will still act on this object, but this time, if I remove the buoyant force from down here, so you're going to have the weight of the object. So let's remove the string as well. So let's say this is our object that is wholly immersed in a fluid. And then there are two forces that we should take note of. So we have first and foremost, the downward force due to the weight of the object. So this is the weight of the object in air. So this, remember, is given by mg, the mass of the object multiplying the gravity that is acting on the object. Now we've just seen that if an object is immersed in a fluid, it is going to experience an upward force, and this force, we are calling it the buoyant force. Now, if you guys can go back to your discussion on Newton's laws, when we combine two forces, since forces are vectors, these are going in the same direction, we see that what we can get from this is the net force that the object will experience. And the net force, since the two forces are going in opposite direction, we can define which direction we want to take as positive. But in most cases, when dealing with these forces, the direction of motion of the object is usually taken as positive. So most books will take it, since this object is sinking, most books would take the downward direction to be the positive one, meaning the weight in air will be taken as positive, and then the buoyant force will be taken as negative. So this is the equation that you guys have to keep in mind. Now, the net force that we calculate in this with this equation is the force that will be sometimes will be referred to as the apparent weight of an object when it is in a fluid. So it kind of explains why objects will be lighter in water. If you have ever been in a swimming pool and then tried to lift your friend, you notice that it will be easier for you to lift your friend when you are in water than it will be to lift the same person when you're in air. Why? Because if you're in air, what you're trying to lift is the full weight of that person in air, which is mg. But if you're now both in water, you are going to have the buoyant force kind of helping you to lift that person. It kind of reduces the force that you have to overcome. In the end, all you have to overcome to lift your friend, it's going to be the net force that you're going to have, or the apparent weight. Okay, now with that in mind, one other thing I'd like you guys to just look at or to keep in mind is most questions will either give you the volume of the object that is going to be partly or wholly immersed. If not that, then they'll give you a way of calculating the volume. So that can be done by specifying the shape of the object. Sometimes you're going to have a cube. If not a cube, you can be given shapes that are familiar to you, like something like this, where they specify the dimensions of this object. So with this, you should be able to calculate exactly what the volume is and then see how to find the buoyant force. Okay, so with that in mind, let's see if we can apply these concepts to a full question and see if we can get it correct. Now, okay, so let's look at this question that I left you guys with in the previous video. So having gone through an introduction of what Archimedes Principle is, I hope you guys are able now to work it out all the way to the very end. So if you haven't tried it yet, you can pause the video and try to work out this question. But then if you have, let's go right ahead and calculate or try to find the solution to this question. Now, what are we trying to find? The first part, they're asking us to find the volume of this material. Now, what material are we talking about? The question is saying a sample of an unknown material appears to weigh 300 newtons in air and 200 newtons when immersed in alcohol of specific gravity 0.7. Now, how do we get this volume? Well, what we have to look at first of all is what formulas can we actually use to find volume. Now, let's look at our expression for the forces that are actually acting on this. Since we're given the weight in air, and in this case, the weight in air is given as 300 newtons, and the weight in alcohol is given as 200 newtons. I hope you guys are able to tell that this value which is given as the weight in alcohol, it is actually the apparent weight, because this is the weight that this object has when it is immersed in alcohol. So this time we're not really talking about air and water. We're talking about air and alcohol. So the only thing missing here is the buoyant force. Okay, now what's the relationship between these three factors? Well, the equation we derived. So the weight in air minus the weight in alcohol, which is just the apparent weight, if you guys recall, this is what gave us the buoyant force. So, okay, let's make sure this is the right equation. Yes, this is. So with this, okay, let me just use the same notation. I had FB for buoyant force previously. So since the weight in alcohol is given as 200 newtons, the weight in air is given as 300 newtons. When we get the difference here, we see that the buoyant force, FB, becomes 100 newtons. Okay, now that we found the buoyant force, how can we relate this to the volume of that particular object? Now, we have to recall, we said when we're stating, when we're driving towards Archimedes' principle, we did specify one thing. This buoyant force is actually equal to the weight of the fluid displaced, which is in this case the weight of the alcohol displaced by that particular object. Now, how do we get that particular weight? We know that weight is equals to mg. Now, in this case, we can use the relationship for density is equals to mass over volume to get the expression for mass that we can substitute there. So we see that mass can be written in terms of the density and the volume. So if we make this substitution, we see that now we have the buoyant force, which is equals to the weight. Now the weight, we're writing it as the density multiplying the volume multiplying gravity. So in this case, what we're trying to find is on the right-hand side, we're trying to evaluate the weight of the alcohol displaced by this object. So here we should have the density of alcohol. So let's write rho LC to mean the density of alcohol. This V is going to be the volume of alcohol and G is still gravity. Now, if we look at this, we can make V the subject of the formula since we already know what the buoyant force is. It's that 100 newtons that we found earlier on. So the only thing that we have to do here is to make V the subject of the formula. So from here we see when we divide both sides by rho and G, we end up with 100 divided by the density of alcohol multiplying gravity. This will give us the volume of alcohol that is displaced. So we know what G is, but the question is, what is the density of alcohol? The question kind of gives us the specific gravity of this object. Now, we know what specific gravity is. So in this case, we have to recall that specific gravity is equal to the density of the substance, let's say rho O, divided by the density of a standard substance. In most cases, the standard substance is water. So if we use that, we have that 0.7, the specific gravity. This is equal to the density of the object. The object in this case, or the substance in this case, this is alcohol. So you can have alcohol here, and then the density of the standard substance, that's water, which is 1,000. So when we cross multiply here, what we have is the density of alcohol is equal to the 0.7 multiplying the 1,000. Now, the 1,000 I used here for the density of water, it is in kgs per meter cubic. And the specific gravity doesn't have units. So when I cross multiply here, the product I end up with is going to have units of the kg per meter cubic. So this, of course, is going to end up as 700 kgs per meter cubic. Now, having found the density of alcohol, I can then find my volume. V is going to be equal to that buoyant force divided by the density of alcohol multiplying G. And if I evaluate this, the volume of the object comes out as 1.46 by 10 to the power -2 meter cubic. So this was just the first part. Now we move on to part B. What are they asking us to find in part B? So in part B, they're saying we have to find the density of this material. Now, wait, we did say this volume we are calculating here, it is the volume of the alcohol that is displaced. You might be wondering, well, the question is asking for the volume of the object. Why are we saying this is the final answer? If we go back to how we started this, we did specify one experiment you did back in high school, where we determined the volume of an irregularly shaped object using this particular experiment. And it was noted in this experiment that by measuring the volume of the displaced fluid, we can conclude or we can determine the volume of this immersed object. So in our calculation, the volume we found was of the displaced alcohol. So this same volume will be equivalent to the volume of the immersed object. So by finding that value, which is the volume of the displaced alcohol, this will be equal to the volume of the immersed object. Now, what is remaining is to find the volume, the density of this particular object. Now, how do we do that? Well, density is equal to mass over volume. We already know what the volume is. What is remaining is to find what the mass is. So we go back to old school formulas. We did specify earlier on that the weight in air was given by the mass multiplying the gravity. So from here, since the weight in air was given as 300 newtons, this then can be given by multiplying the value of the mass that we are trying to find times gravity, 9.8. So if we divided both sides by 9.8, we end up with 300 divided by 9.8, giving us that value of mass. So from here, we can then conclude that the mass of this particular object is actually given by 30.6 kg. So if we get this value and substitute it in our formula for density, what we have is 30.6 divided by that value for volume that we found earlier on, which is 1.46 by 10 to the power -2. What we get as our density is going to be 2.10 by 10 to the power 3 kgs per meter cubic. So this is the density of the object we were expected to find. So how did you find this? What values did you find? I hope you were able to work it out. All right. Now, having seen what happened when something is wholly immersed, let's look at another situation. Let's look at another example. In the next example, what we're trying to look at is this. Yeah, you can just try to go through it, really. Try to read through the question and see if you're able to pull it out. So in this case, what they're saying is we have a small ferry boat, and then they're given the dimensions of this, of its base. So we have 4 meters wide and we have 6 meters long. Now they're saying when a loaded truck pulls onto it, the boat sinks an additional 4 centimeters into the river. What is the weight of the truck? Now, one key thing that you have to get, you guys, in this case is, let's look at, first of all, that base of the ferry. So if this is the base, all that we're saying is one section is 6 meters, the other section is 4 meters. Now, of course, when this is, let's say, in water or seawater, whatever it is, the boat, of course, is going to have some section of it already immersed in the fluid, whatever it is. It's going to have some section of it already down there. This section is going to be due to the weight of the boat. Now, what the question is saying is, when you load a truck onto this boat, so let's say this is our boat again. So when you load a truck onto this boat, what is noted is that the boat sinks further. So initially, let's say you had a small portion of the boat. You can even say, you can even make it a little bit more so that you can easily relate to. So let's say this is what you have for the boat. So when a truck is loaded onto this, a larger portion of the boat actually gets to sink. So let's say now you have all this part that gets to sink. So if initially what you had, the section of the boat that was inside the fluid was only this part, now we're saying that part is going to be like down all the way there. So let's say this was initially what was inside the fluid or inside the liquid. Now this additional section, let's color it up so that you guys can actually see it. So this additional section here, this is what sinks because of the loaded truck. So the truck causes this additional section to sink. Now what we're trying to find is, what is the weight of the truck due to, what is the weight of the truck? Exactly that, just the weight of the truck. Now we are going to use the fact that the truck makes the boat to sink by this factor or by this volume. So this is the volume that we are interested in. Now the thing is, the key is, you're trying to avoid the section which was already inside the fluid, because this is due to the weight of the boat already. All you want to see is, what effect did the truck have on this boat? So the first thing that we note is the volume. The truck displaces a volume equal to this section that is colored in blue. So what we're trying to find is, what is the buoyant force that will be a result of this volume? So the buoyant force here is going to be given, just as we saw earlier on, buoyant force, mass, it's equal to the weight of the displaced fluid. And we know the displaced fluid will have the same volume as this section in blue, the section that sinks. So the weight of that section will be given by rho V, which is density times volume, multiplying G. So this section is going to give us the weight of the displaced fluid due to the sinking of this section. Now, what's the relationship here? Well, what happens is the boat kind of sinks, but since it only sinks partially, it stops sinking afterwards. It means that when you evaluate the section that sinks, when you evaluate the weight of the truck, because the weight of the truck is the one that actually pushes the boat down. So this weight is going to be opposed by an upward force, which is the buoyant force. Now, earlier on, we did see to say that this kind of gives us, the combination of these two gave us a net force. This was given by, we took down to be positive. It doesn't really matter which direction you want to take as positive, just state it. So we took down to be positive, meaning our weight in air was positive, minus the buoyant force. Okay, sorry, I wrote F air there as well. So this is the buoyant force. So in this case, for this particular question, what happens is that the boat doesn't really get to sink, doesn't get to continue sinking. It only sinks a certain section and then it stops. What does that imply? It means that after that section sinks, then these two, it's more like they get to be equal. It's like the net force becomes zero. This kind of makes sense. If you think about it, if the net force was not really zero, then you expected this to be equal to ma according to the second law, where this is the acceleration at which the boat is sinking. But because the boat doesn't continue sinking after that 4 centimeter dip has taken place, it means that there is no acceleration and the difference must equate to zero. So when you subtract the weight in air, which is basically just the weight of the truck, minus the buoyant force after that 4 centimeter dip, the difference must give you zero. So in other words, the buoyant force and the weight of the truck are basically equal in this case. But what we have to take note is the buoyant force in this case is actually just proportional to that part, that section, which sank due to the truck. Now, how do we find that? To find that, we recall buoyant force is given by the weight of the displaced fluid. So what fluid are we dealing with in this case? So in this case, let's say we're dealing with water. So it's the density of water, the volume of water displaced, multiplying gravity. So let's take the density of water to be 100 kgs per meter cubic. G, we're going to take it as 9.8 meters per second squared. It is an acceleration. And then lastly, well, what is V? Now, this is the volume of water displaced. And just as we discussed earlier on, the volume of the fluid displaced, it is equal to the section that actually sinks, the section or the object that displaces it. In this case, again, we are only looking at the blue section. This is the one whose weight we are trying to find, whose influence we are trying to find. Not really weight, it's whose influence we are trying to find. So by getting the volume of this section, we would have obtained the volume of the water displaced. And then we get the weight of that water to get the buoyant force. Okay, so in other words, to get that volume, since we're given the dimensions, taking this as a rectangle, we have 4 this side. Actually, let's say we have 6 this side, 4 this side, and the height is given as 4 centimeters, which is 0.04 in meters. So the volume can then be obtained by multiplying this product or getting this product. So that is a 6, a 4, and a 0.04. So if we make our substitution here, we have the density of water, the volume, which is 6 by 4 by 0.04, then by 9.8. So if we evaluate this, we see that we obtain the weight in air or the weight of the truck as 9,408 newtons. So this, we can write it in scientific notation as 9.41 by 10 to the power 3 newtons, or you can write it as 9.41 kilonewtons. So whichever method you want to present your answer, it's still okay. All right, so I hope you guys were able to follow through both examples. It was a little bit long, I think, but I hope you guys were able to follow through. So let me get your reactions, you guys. Let's see how you found this video, how you found each example. What methods did you use really? And which example do you feel was more straightforward, more easy to work out? Yeah, let me hear all that in the comment section. Let's interact there. Otherwise, for our next question, I have one interesting question that I want you guys to look at. So yeah, so here we're talking about a bone and what is happening to a bone. So we're kind of moving away from fluids at rest. The last question we're going to do in this series is going to be about more like Young's modulus. So you guys can go through this question, try it out. Let's see what you find. Those who try it out and actually get to find the correct answers, you can leave your approach in the description, in the comment section. Let's hear how you found, how you worked it out, so that hopefully someone else can try to use the same methods. Otherwise, I will see you guys in the next video. This was your tutor.